Hello and welcome, ladies and gentlemen, here at the Technical Forum at the group exhibit Hydrogen, Fuel Cells and Batteries on the Hannover Fair in 2018. I invite you to come here, join us, sit down, order a drink and enjoy the next presentation. Our speaker will be Professor Dr. Ralf Wehrspohn, the Vice President at the Association Hydrogen Power Storage and Solutions East Germany, and he will now speak about the progress and perspectives of the hydrogen projects in the HYPOS Initiative. Please welcome with me Professor Dr. Wehrspohn. There you go.
Yeah, thank you very much for this kind introduction. Yeah, actually, I'm very happy to present our network, which has been established 3 years ago towards cost-efficient green hydrogen. And let me go through some slides to bring you closer to our network, which is based in East Germany, in central East Germany. Perhaps, first of all, some figures. What is probably not so much known is actually that in the eastern part of Germany, we have a 150-kilometer long hydrogen pipeline. It's managed by a couple of companies, but Linde is a major owner of this pipeline. It's linking all the chemical sites in East Germany towards from one side to another. In addition, what we have also, what is probably not so much known, is most of the natural gas reserves are stored also in our region because there's a lot of salt there, and so there are a lot of salt caverns. Currently, they're all used for fossil gas, but the future could be clearly also to store hydrogen there. And I will come back to this in a minute. Then what is the hydrogen demand in our region? The hydrogen demand only or mainly by the chemical industry is 4.8 billion cubic meters per year. So cubic meters in kilogram, if some of you are not so familiar, just divide by 10, okay? So that's essentially 480 million kilograms, 480 million, so 480,000 tons of hydrogen each year unused in the region. So that's a huge amount. Most of that is actually, and this is what my predecessor just told you, is used by water gas shift. So most is intrinsic to the process as the hydrogen. So really that part that can be substituted by green hydrogen is roughly about 1.25 billions of norm cubic meters per year. So if we just take that one, which can be substituted by the pipeline, it's about 0.6 billion cubic meters per year. And if you make the calculation, that corresponds now in power to a power plant of 350 megawatt constantly running to produce by electrolysis only the small amount of 0.6. Okay, to give you round, 350 megawatt. So if you want to use this in solar energy, for example, it turns out that last year in our core region, we had just the right amount of solar energy, but it's a whole solar energy in the East Germany, which could produce roughly 33 terawatts hour per year, which corresponds to 350 megawatt power plant full-time running. So it's feasible. It's not that far away, essentially, to substitute that amount of. So the electricity is there. And if you look at the wind energy, it's even 3 times more. So there is enough energy there due to wind and solar to substitute the small amount. So what has to be done to substitute this? Essentially, we build up a network to bring this further. Currently, nobody is making money with green hydrogen. Obviously, the chemical industry and Linde and other partners are making a lot of money with gray hydrogen. But how can we go from gray hydrogen to green hydrogen, mainly for the chemical industry? That's our question, and that's our network for. So we want to have a cost-efficient economy of green hydrogen with focus, obviously, on the huge consumers of the chemical industry. And therefore, we created 3 years ago this network of small and big companies which are part, essentially, to make this transformation. So essentially, this was stimulated by some external power or money, if you want. So the BMBF funded this by 45 million euros within a period of 5 to 6 years. And so this will essentially stimulate the needed transfer of the technology to green hydrogen technology. As I mentioned, we had a lot of phases already. We are currently in the way of setting up the first pilot lines, and I will show you 2 examples of pilot demo scale activities we are currently setting up close or within the chemical parks. So here you see the value chain. I think I don't have to explain it in detail. The main major difference is probably we have hydrogen pipelines and we have large-scale storage, so we can have also essentially salt cavern use for hydrogen storage. So that's probably the main uniqueness of our region, is this one and this part here. All the others are essentially similar, and obviously the need for refineries and chemical industry. What were our methods? And I don't want to show you the slide, it's too complicated. How have we evaluated our ideas? We essentially developed a tool which called H-Index. And the H-Index evaluates every innovation concerning their cost efficiency at the end product. So the typical value chain of our green hydrogen has about 37 value elements, starting from electricity, then transport, conversion, etc. And if you have one innovation on this road, you can put it in this tool, and then it gives you a number how much the end price of green hydrogen is essentially reduced. So that's for us our benchmark to classify projects from just incremental innovation or not needed innovations to really innovation needed for our case. So that was the main part. We call this H-Index, which is the main benchmark for us to bring things further, because we need some clarification what is the real cost decrease in instant. So you see we have a lot of projects in the hydrogen. We have essentially transport and storage, which a main focus on transportation in the grid and also in caverns. Also the reuse of old gas lines could be thought, and then obviously the news in the chemical industry as major focus. So these are the projects. These are just the project status, and I don't want to go too much here into detail, but this is the project pipeline. So of our projects, they have been all evaluated concerning their efficiency to reduce the hydrogen price of green hydrogen, and we are currently starting more projects here. So we will have about 10 more projects then within the next years. And obviously, this is an open network, so everybody is happy to join there on this network and to participate in our network. It's an open network. I'll come back to this. So I want to show you 2 flagship projects, which are probably somehow uniqueness. We are currently setting up an electrolysis platform within the chemical park, managed by Fraunhofer and Linde, where we essentially can insert large-scale equipment of electrolyzers to evaluate their integration in a chemical park. Because currently most of the pilot projects are decentralized projects. So we have hardly any centralized project where we are really in a chemical plant, where we're really in a chemical site, where we are connected to a pipeline. So with all the question of purity of the gas, then what is the feed flow and so on. All this will be essentially started here in this project. We start with a 2 megawatt, a starting point. Plans are for 10 megawatt integration. We want obviously reduce this, want to have the operational cost, and we see a lot of cost reduction by the integration of this project in the pipeline. We have also Infineon and Siemens in the project, in particular because 30% of the cost is the power electronics and all the electricity. And in this project also, we have to bring down also the power electronics, which adopted to the chemical questions. So this is our pilot plant within the chemical triangle, and this is one, and we have essentially placed for 4 electrolyzer systems. So 3 of them have already been granted in other projects, and we have 1 more left with Linde and Fraunhofer, which can be installed there. So we have 1 more slot from the 4 slots, which can be feeded into the pipeline. 1 more slot is left, and we are happy for propositions to join us. The second thing is probably even more courageous. It's really to make the first salt cavern for hydrogen in Germany, which is connected to a pipeline. And so that is a basic idea. Here our strong partner is VNG, which is a gas storage cavern. They own all the gas caverns actually in the region. They also have a big net of cavern. And so we want to start here realizing the first German hydrogen cavern. We start with a research cavern, so on a pilot scale, to see how that works and also how the business model is, because it goes over numbers. Hydrogen will be produced, obviously, by connection to the pipeline. And there's obviously the first question, should be electrolyzers close to the pipeline or in the chemical park? Because in the salt cavern, it's all wet. So the question of humidity, quality, and so on, if we want to go 5.9 hydrogen in the pipeline, we have to design the thing correctly so that's the cheapest, but also requires the 5.9 quality of the system of the pipeline. So this is a big issue which is not quite clear yet. One possibility could be that we put a big electrolyzer farm just on the top of the cavern and then essentially put the wet hydrogen in the wet cavern and make the purification later. Or we have the electrolyzers in the chemical park and have just a pipeline going back and forth. So this is currently in the project evaluated cost-wise. We're not quite sure what is the best on the cost because there are a lot of questions about the pipeline itself, and most of the cost is actually of this cavern is on the purification and the pressuring. So the cavern, the small cavern, I have to admit, the small we will have 42 million of norm cubic meter operating gas. So remember what I gave you before, the numbers. They were about the whole consumption is 4.8 billion norm cubic meters. So that's obviously a different number. So this will be essentially for storage the fluctuation, which is either coming from the grid or coming from the users of the chemical industry. The implementation and filling is planned for 23-24. So this project is currently running, and the major task is cost effectiveness and security, obviously. Security, if you make the first hydrogen cavern, then obviously security is a big issue. Acceptance, we have also a project on acceptance because this obviously changes a little bit also the acceptance of the population. So these are two flagship projects. We have much more, for example, in how the pipeline looks like, how can we use old pipeline, do we need metal pipelines, could we use cheap plastic pipelines connecting. So there are a lot of other questions we address which originates from our question, which have not been really addressed and which are relevant for bringing essentially us to a green hydrogen economy, which is the aim obviously of all of the partners and also the chemical industry in future if you look at their strategy papers, Chemistry 4.0. Yes, so essentially the next question is what about price and what about quantity? So we believe with all our things the price can go down definitely to 3 euros per kilo with all the innovations. The question is what is the real price of production? That is obviously lower. We don't want to speak with what is the real price of production of grey hydrogen. We know this obviously. This is a long way. But the point is, I think if we go for 3 euros, we are already interesting for a couple of applications so that the green H quantity can up and that with the economy of scale, essentially the prices go down. We are very confident that this will even go down because major costs are at the long run, or at the moment are the capex costs, the investment costs. The electricity cost is, if you are in a chemical park, are obviously industrial electricity prices, what we have there. So that means we have prices what the chemical industry uses, and who knows this knows roughly the prices what they pay. So it's really different to what you pay as consumer. It's a completely different number. So that is fine. So we want to invite you here to our network at the end. This is a network which is open. It's an association society. We have different formats in discussing with stakeholders, but also with our partners. I'd like to invite you here to our next forum, 16th, 17th October in Leipzig. It's in the BMW manufacturing site because BMW, as you have seen here somewhere, they're also much interested in the technology of hydrogen, so we will be there. And you are invited to join us. Please go on our website. And we have also dialogues where we make working groups. We are connected to the major initiatives also in the European Union, but also in other frameworks. So we are very interested also in having dialogue platforms on this point. Yeah, the members are, you see the member potential, we are about 105 members, so it's open also for other members to join us. We are looking very strongly on companies, obviously 70 business partners, 32 research partners, and if you go out of the company, we also have honorary members for long-standing people in the company, so in academia, who just help us managing this association, because we do not pay our board, and the board needs obviously manpower, and so we're happy to have people who come from Air Liquide or from Dow Chemical who help us on this point. So this is our board. I'm the vice president or deputy chairman. Chairman is from Siemens. Mr. Potze is from the VNG. We have other partners. So you're happy also to join or contact us. Thank you very much for your attention.
Yes, thank you, Professor Wehrspohn, for this interesting presentation. We still have time left for one or two small questions. Is there any question in the audience? Okay, I can't see. Yes, maybe one there. Please introduce yourself shortly.
My name is Xiaodong Jia. I'm Chinese from China. Yeah. My question is, in your network or partnership, so is there any oil and gas industry mega player like ESCO or BP or Shell, and what kind of roles they are playing, and what is their, how to say, expectation from this kind of partnership?
Thanks.
Well, after the reunification, the big side of oil is going to Total. The big refinery in East Germany, the biggest refinery, is owned by Total, and Total is obviously an important partner in this consortium. Yes, and it's the biggest refinery, in, actually close to Schwedt, but it's the refinery in East Germany. It's producing 30% of the diesel still for Germany. So we are currently, but it's an open network. So we are not limited to one oil company. We are also in contact with other oil companies. But if we are integrated in a network, we also need partners who make their exploitation in the region. And therefore, because they are in the region, they are our preferred partner.
Okay, thank you.
Is hydrogen storage in the caverns the main target, or is the methanization of hydrogen another idea? The methanization of hydrogen in the caverns, is that another idea?
Yeah, the question was methanization or hydrogen, what do we want to store? So for VNG, they store what gives the best price. Very simple. Okay, so fair enough. So natural gas doesn't bring any money currently, because the spread, winter-summer spread, is more or less zero, so they don't earn any money anymore. So the question is, do we store synthetic methane or hydrogen? Currently, Linde is essentially will be connected to the cavern, so major storage product will be hydrogen for the first part. But at the long run, obviously you're correct, one could store also other things. Actually, you don't need to store gas, you can also store liquids there. So also liquid precursors, chemical precursors. But our main focus is currently hydrogen, because we want to be connected to the grid. The storage of methane is already done, because there's nothing to do, and this can be inserted directly into the network, into the grid. So there's no need for research actually on that point. But this is not our main focus. Main focus is here, first hydrogen cavern, small one. We start with a small one in Germany. Yeah.
Okay, thanks for the questions, thanks for the audience, and thanks again, Professor Wehrspohn.
Yeah.
Is it possible to speak with you later, if anyone
yes,
from the
sure.
audience?
Sure, I'm here.
Okay,
here.
and you can find HYPOS Initiative at booth number E51/1. Okay, and we will have the next presentation right ahead. The speaker will be Dr. Markus Tegel from Fraunhofer IFAM with his topic Power Paste for Infrastructure Independent Hydrogen and Energy Solutions. Stay tuned. See you there.